Hello everyone, I'm Sang Kim in the Guide Wave Analysis LLC. I would like to demonstrate guide wave inspection and monitoring GIM software with a GWT demo pipeline. Here are three items: GIM software, GWT demo folder, and a schematic drawing or pipeline. This pipe has two ends, two defects, and two pipe spots. The MSS probe was installed at about 0.8 feet from one end. It is a 2 MPS and Schedule 40 pipeline. This is a welcoming screen of GIM V6 software that was launched in 2024. Click on the Start push button. The GIM software consists of 5 sections: acquire data, select data, calibrate distance, calibrate percentage reflection, review, and report. This is the acquire data section. Let us recall data in GWT demo folder. Click on the recall push button, select the demo A folder, and click one of the data files. This is 128 kHz data. Once the data is opened, the software will display magenta underline in the operating center frequencies. It is 45, 64, 90, 128, 180, and 250 kHz. We can easily select the different center frequencies, for example, 180 and 250, 45, 64, and 90 kHz. During field testing, the software supports inspection 4 different data display. They are RF data plot, the rectified RF data plot, video data plot, and spectrogram data plot. It also has 4 different views of data: a symmetric view, top-bottom view, parallel view, and overlap view. In symmetric view, we can see both sides of the pipeline, and MSS probe is located at 0 feet. These are reflected signals from 2 pipe ends. All other signals are reverberation signals between 2 ends. Let us check pipe information. Click on the pipe information menu. The pipe information is used for inserting general information of pipeline and inspection, such as inspector, enlist, client, pipe size, inspection site, pipe ID, test location or tracking number, pipe surroundings, pipe condition, coding types, product carried, type of pipe spot, pipe temperature, and report notes. The nominal pipe size can be easily inserted by checking and the schedule push button. The current pipe is a 2 MPS and Schedule 40 pipeline. Then everything is okay. Click on the Save and Exit push button for closing it. Before field testing, we need to check the dispersion curve of these pipelines. Click on the dispersion curve. A new window shows for torsional mode dispersion curve of 0.154 inch wall pipe. That is our testing pipeline. If we set x-axis maximums to 1 MHz, we can see 3 torsional modes: T01, T02, and T03 wave mode. T01 is a non-dispersive mode that has a constant velocity at any frequency, but T02 and T03 are dispersive mode that has increasing velocity as the frequency increases. The cutoff frequency of T02 mode is 415 kHz. This is a frequency suggestion for inspecting this pipeline. Because the wall thickness is thin, 64 and higher center frequency are suggested for inspecting this pipeline. Let us close this window. Let us move to Select Data section for analyzing data. Click on the Select Data push button. This is the Select Data section for selecting RF and video data for analysis and reporting. Data for analysis subsection has 6 video data that was selected as RF data. If you click on Data Preview, you can see the rectified RF data, original 6 data sets. Move back to Data for Analysis. If you want to add other video data, you can click on Data Control pop-up and select Add Video Data on the list. Here are three data sets. Top is acquired RF data plot, middle is video data at 90 kHz, and the spectrum plot was reviewing for frequency spectrum of RF data a long distance. You have two controls of noise percent and the spectrum window. If it changes noise percent, such as 0, you can see change it, 40%. You can change spectrum windows, very narrow and very wide. If you want to add 80 kHz video data for analysis, insert 80 in the frequency edit box and click on the record push button. Now we can see 80 kHz video data on the top of the tracer, but we are okay only the center frequency video data. Therefore, we will delete. For data analysis, we need three calibration: distance, amplitude, and attenuation in the next step. However, it takes time and difficult to do with the 6 video data sets, especially those processes are highly dependent on the inspector's experience and knowledge. The easy way of calibration is a drawing pipeline by matching the ultrasonic signal and the geometry feature. Click on the pipe drawing menu. We have a window of drawing pipeline using video data plot. The schematic drawing of pipeline has only one MSS at 0 feet. Click on the end of pipe checkbox and click on the two signal at about -0.8 and 6 feet. Click on the x-axis range edit box and insert -3 and 10 feet. Click on distance reference push button on the top right corner. The current reference is MSS at 0 feet. Click on the EP1 text and insert 0 feet. Click on velocity calibration push button. The current velocity is 128 inches per millisecond. There is a nominal velocity of shear wave in steel pipe. If you know the distance between two geometry features, click on the velocity calculation pop-up. Select the distance between two features. Click on the EP1 and EP2. The current distance is 6.735. For example, let us insert 6.7 and apply push button. The velocity has calibrated. The drawing and the data has changed with the new velocity. Let us proceed with the nominal velocity of this analysis. Insert 128 in velocity edit box. Click on Mark Selection for checking proper selection of data. All geometry features are properly selected. Click on the menu pop-up and select Amplitude Calibration. This is Amplitude Calibration window. The software has selected the closest geometry feature EP1 as the reference, and each reflection as 90% at the 6 different center frequency. The pipe end is a 90-degree cut at one axial length. Each reflection has the same because the geometry feature is not related to wavelengths of the operating center frequency, but each reflection is not 100% because of a mode conversion at the pipe end. If you are happy with this amplitude calibration, close this window after saving the modification. After inserting all the information in pipeline drawing, click on the Review and the Reporters section for finding indication after automatic calibration, distance, amplitude, and attenuations. Before explaining the Review and the Reporters section, let us review automatic process using pipeline drawing first. Click on the Calibrate Distance push button. The Calibrate Distance section is used to calibrate the distance of data. It includes velocity, data shift, distance reference, and zero offset. With the pipeline drawings, the software has automatically aligned two pipe end signals. Click on the zero offset push button. Click on the different data set. Zero offset value is different. If everything is okay in the distance calibration, click Calibrate percent reflection push button. The current window is showing amplitude calibration with the reflection reference signal and its amplitude. The reflection reference is EP1 at 0 feet and its value is 90%. That was done in the pipeline drawings. If you want to change it, insert a different value, for example, and 50. You can insert. You can see deflection 55% per division. So this one is a slightly lower than per division because this is 55, this is 50. However, all other one is 90%. Only this blue solid line signal was changed. If you want to change it, all data set, click the reflection reference push button again. Then all data set was selected. Insert 50%. The percent deflection of all data set has changed to 50%. Please see the y-axis scale. This is 33% per division. This is one division of them, and then this is 50% amplitude. If you want to go back with the original setting with the pipeline drawings, insert 0 for reflection reference. Then everything becomes 90%. Now move to attenuation. Click on the attenuation push button. The software has calibrated attenuation, making two pipe end signal the same. If you click on the different data tracer, you will review the attenuation value. If you will calculate the signal by clicking two data sets, click this one and this one. The software automatically calculates by making two end signal is the same. If you want to change it, all of the data, click and the attenuation push button again. Insert, for example, 0.1. Then you can see all data set has the same attenuation value, 0.1 dB per foot. If you want to calibrate the attenuation using pipeline drawing information, insert 0 for attenuation value. Then attenuation is calculated by making two end signal and the same for every video data. Let us check the automatic threshold calculation. Click on the threshold level push button. It shows the threshold levels with a solid green line for each video data. Let us increase y-axis amplitude for reviewing the threshold levels compared to background noise level. The threshold level is decided with three values of threshold level, range, and threshold rate. For better explanation of these values, click on the one icon. In one icon, we can change the threshold level at each center frequency. The threshold level consists of constant and exponential increasing line. The threshold level is a constant percent deflection amplitude at MSS locations. Increase to 2. The threshold level increases to 2. The range is the distance from between MSS probe and the start of the exponential curve. In this case, 4.9 feet in here. The threshold rate is the coefficient of exponentially increasing curve. If we set 0, the threshold levels becomes a constant through all range. Adjust it and see the change. Click on the all icon for more adjusting of the threshold level. Click on the threshold level push button again for selecting all dataset. Insert 2% and for threshold level. All threshold levels are the same. This is how to set the threshold level the same for all dataset. If you want to set the threshold level based on the background noise level of each data, insert 0 for threshold level. Now let us check the threshold level setting. Click on the analysis setting menu. The ratio of the signal amplitude noise amplitude is 2.2. If your client want to find a big defect, let us 6 for as an issue. Then click on the save push button. Threshold level insert 0 in here. Threshold levels became 6 times of noise levels in here. The threshold level has increased. Click on the indication preview. So let us set the default value of signal to noise ratio. Click on the analysis settings again. Select the default. Then this one becomes 2.2. Save it. Then we select one more. Everything is selected. And then we insert 0. The threshold level is on the 2.2 times high of background noise level. Click on the indication preview. for checking the findings. Now we know that automatic calibration process of the software with the inserted geometry feature information. Click and review and report push button. Click on the yes for replacing the indication. This is a review and report window showing all indication with the automatic calibration. Let us insert the visual testing information first. Click on visual testing menu on the top. This is a window for inserting visual testing information. The initial selection of a measuring reference is MSS signal. Let us change it to EP1. EP1 location became the 0. Click on the Insert Push button and click Pipe Spot. Insert 2 and 6 in the Distance Edit box. Apply Push button. 2 pipe spots are inserted in the schematic drawing or pipeline. Insert a comment on the PS1. For example, this is wooden spot. If there is a 4-branch pipe at a distance regular interval 1.5 from PS1, click on the branch pipe, insert 1.5, colon, 1.5, colon, and 6. Click and apply push button. This is a 1.5 from PS1, every 1.5. There are 4 branch pipe was inserted. If you want to delete, click on the change push button. Select the delete checkbox. Select all the signal to delete. If you click on the EP1, it shows an error message because EP1 is made in the pipeline drawings calibration. It cannot be deleted in the visual testing. Once the 2 pipe spots are inserted, close the window and save yes. Click on the VT icon for displaying the visual testing information in data plot. The PS1 and the PS2 are shown on the top of the data plot instead of a signal. All ultrasonic signals such as EP1, X1, Q1, Q2, Y1 are shown on the top of the signal because they are ultrasonic signals received with a guide wave probe. Click on the UT image checkbox. Click EP1 here. The selected signal is marked with a solid green line on the top of the signal. The information of a selected signal is shown next to comment text. It is 0 for X location, 90% for Y amplitude, and 0.84 for the relative distance from MSS probe, and 35 for signal to noise ratio. The detailed signals are shown here, the rectified RF and the spectrogram plot. The initial signal width is 3 feet. It can be between 0.5 and 6 feet. 0.5 and 6 feet. Let us insert 1 foot. A spectrogram plot can be changed. The spectrogram window and the noise percentage. For example, very wide and very narrow or medium. Select the Q1 mark. The details data plot at 1 foot width shows the background noise level and the signal amplitude and the signal width. The vertical spectrogram plot proves that it is a fundamental torsional mode and T01. Select the Q2 mark. It is a real indications. The spectrogram plot is a vertical line for fundamental torsional mode. And click on the Y1. It is a multiple reflection signal from the round trip distance between Q1 and EP1. If you click the signal at 2.8 feet, the software tells that it is a multiple reflection of Q2 and EP1. If you check the detailed image and a spectrogram of a selected signal, you will find that the frequency spectrum of a real indication is like that of the pipe ends. The mirror and the multiple reflection signals have a distorted frequency spectrogram near the center frequency. For comparison of the signal of indication at the same trace, click on the one icon. The one data plot is easy to compare. Frequency spectrum of several signals EP1 and X1, Q1, Q2, Y1. The real indications are similar frequency spectrogram. For example, Q1 and Q2 is a vertical line, is similar to EP1. However, and X1 and Y1 is a different frequency spectrogram. Compare the frequency spectrogram at different frequency. In here, 45 and 250. If you select the Q1, selected signal is marked with a solid green line, and its RF signal and the frequency spectrogram is displayed on the left side of the video plot. The data acquired at different center frequencies are independent, even though it's data acquired using the same MSS probe and pipeline. By comparing the signal detected at different center frequencies, we can confirm that the indications are real. Click on the All icon. Click on the Report push button for reporting the result. The report has 4 subsections of summary, UT image, picture, and groupings. This window shows a summary subsection. Summary subsection is used for inserting summary in the report. Select the inspection range and set y-axis amplitude for clearly displaying the signal. The summary is most important in GWT report. Insert information that summarizes these inspections. Before we start this one, we inserted some reference summary in here. Click on the notepad icon, copy it, and paste it. The summary says 2 indications need to be checked using identity method. 2 artificial defects were detected 180 and 128 kHz. 2 defects was a half wall and quarter inch diameter. 128 is the highest amplitude because the quarter wavelength matches the actual length of defect. Click on the inspection range push button. 2 red dotted are drawn for indicating the inspection range. The inspection range can be inserted by selecting signals using mouse. If you click on about -1, software automatically updates -0.9 and 6.7. But its inspection range is between EP1 and EP2. Click on both signals. Now let's insert TCG y-axis maximum. These values you can insert in the edit box or increase the slide. Y-axis maximum should be increased for client to clearly see signal amplitude and noise amplitude for checking signal to noise ratio. For changing y-axis maximum value individual data plot, click on one icon. The top is a TCG data plot and the bottom is a video data plot without attenuation compensation. The bottom plot includes a 5 and 15% depth curve, distance and amplitude correction curve. TCG data plot is much easier check and compare signal amplitude because the y-axis is linear scale and it is applied to signal at any distance. On the other hand, the bottom data has not compensated the attenuation on signal, so that it must use a depth curve for comparing signal at different distance. That curve is only useful for visually showing the attenuation along long distance. Move to different frequency and check the amplitude clearly showing the finding. Click on the All icon and click on the Approve push button for saving the report. After generating the report, the temporary files are deleted. Click on the Data folder menu for checking report. We have 2 PDF files. Open Demo 1 underline report PDF file. The first page shows the basic information, type information, summary, and the table. The table shows both ultrasonic findings and visual findings. Visual findings have a VT text for percentage reflection, and it is written with a green color. All ultrasonic findings have a percent reflection value in the table, written with a different color except the green color. The guide wave testing is mainly ultrasonic testing method because it finds defects in pipe wall and estimate defect size, so that the visual testing finding should be written with a VT text for differentiating from the ultrasonic findings. The second page is a schematic drawing of tested pipeline with all findings. The two diamonds at EP1 and EP2 location shows the inspection range. All UT findings was marked on the top of the signal, but all visual testing findings was marked with a green dotted line for differentiating. Let us click the frequency PDF file. This is the frequency PDF file. At each frequency, data plot has three plots: a spectrogram plot, original video data plot, and TCG data plot. This is 45 kHz, and 64 kHz, 90 kHz, 128 kHz, 180 kHz, and 250 kHz. Now let's click on the UT image list. The UT image window has two options of individual mark selection and range selection. Individual mark selection, there are two marks of indication and end of pipe. Click on indication checkbox and select yes for adding all indication symbols. Click on end of pipe checkbox and select yes for adding all of them. If you want to add other signals like X and Y, click on the mark insert push button. Click on X1 signal and Y1 signals. They are added in the selected mark. The selected pop-up menu has three choices of move up, move down, and delete. Select and delete and remove X1 and Y1. Click on the range select list. Click on the range insert push button and select 2 and 4 feet. Two solid red lines appeared for visually showing the range selections. Insert a comment. Corrosion region in the comment edit box. If you want to change the range, move the mouse and click on the signal. Click on the Save push button for saving it. For printing those detailed UT image, click on the Print PDF file list. The software saves the detailed ultrasonic image. For checking the result, click on the Data folder menu. UT image PDF file was made. If we open it, the first page shows a detailed UT image of corrosion regions. With the 2 feet width, the ultrasonic signals are clear for checking the detailed condition of pipe. The second page is a detailed UT image for individual indication. The x-axis width is 1 foot instead of 100 or 200 feet of data plot. With the narrow x-axis width, we can easily check the signal-to-noise ratio and the spatial resolution of indications like ordinary UT testing. This detailed UT image of each indication proves that the guide wave testing method is simply low-frequency ultrasonic testing method. Close the PDF file and click on the picture list. This window is for inserting image files in the report. Selected is all photos in file. If you want to add other pictures, click on the copy picture file. Push button. Move to desktop, this one. Click on the photograph, click and select the push button for adding a list of those selected photos. Add all of them. Click on the selected photos. This is 4 selected photos, and there are 3 menus: move up, move down, and delete. And sort by move up. If you want to add a caption of this file, equipment and the laptop. A caption has changed. Change number of photograph and 2. If everything is selected, click on the Print in PDF file push button. For checking the result, click on the Data folder menu. We have a picture PDF file was made. 2 photographs at each page. Here, first one and the second one. Close the PDF file. Let's click on groupings for merging all PDF files. There is a 3 lists of report list, review summary, and total content. For reportings, 1 report, software automatically lists the current report. Move on to the review summary list. In review summaries, there are two choices of edit summary and change selection. The edit summary is for changing the summary if we want to merge reports tested at many locations. Click on the change selection. The change selection is used to changing the sequence and selecting report list that was made in the summary, UT image, and the picture section. Click on the exact summary push button for merging all report files. Then click on the data folder menu. The three PDF files, report 1, total report, and exact summary was made. With one report, the report 1 and total report are the same. Open the report 1 PDF files. It includes a summary of a demo pipeline and a table and a pipe drawing and total data plot, individual data plot, UT image of a local range and individual indication, and photograph of field testings. Close all the window. Click on the total content list. The total content list is used for include reference files in the final report. Initial screen shows PDF files in the reference folder. Reference folder is located in the PDF report subfolder in the GIM software. If you want to add any PDF files in the report, insert in this folder. The reference file could be certificate of inspectors, calibration report of equipment, or company introduction, etc. If all list of the reference file is added, click on the final report. The final report is generated. For checking the final report, click on the data folder menu. Click on the final report PDF file. The first page is titled PDF files in the reference folder. The second page is a list of content. The software checks the number of pages of each PDF file and generated the page number in the list of content. The report was located between page 4 and 16, and the two reference files are located page 17 and page 29. The total number of pages is 30. Move to page 4. This is a report file of data acquired with a demo pipeline. All PDF report of table, total data plot, individual data plot, detailed UT image, and photos are added. Move to page 17. This shows a reference file of guided wave testing using MSS technology. Move to 29. There is another reference file explaining the conversion of a percentage cross-section area to percentage wall loss in the guided wave testing report. This is an explanation how to use GIM version 6 software for generating inspection report with the guided wave testing data. The process of generating report takes time with inserting geometry features in pipeline drawing and visual testing, reviewing the detailed UT image of every indication along long distance, inserting field testing photographs, and adding reference files. But it will be fun if you are familiar to this software because it includes all tools for analyzing ultrasonic data in guided wave testing. I'll upload many presentation materials about guided wave testing method in this YouTube site. Please subscribe if you like it. Thank you for your attention. If you have any question, please email me at skim@gwanalysis.com. Thank you. Bye.